Hello everyone. So today I'm going to be talking about class 9 to 10's physics book's third chapter, which is entitled as Force and Motion. So I'm going to be talking about all of the important aspects and things about the chapter. So yeah, I'm going to be going through as lesson wise as the book also went. So yeah. So the first one is inertia. So what is inertia and why is it important? So, inertia is the natural tendency of an object to resist and of any changes in its state of rest or motion. This means if something is still, it wants to stay still. If it's moving, then it wants to keep moving at the same speed and direction. There are three types of inertia. There's inertia of rest, there's inertia of motion, and inertia of direction. So, for example, of inertia, I guess you could think of it when a car suddenly turns. Your body leans sideways to the way your car is moving. So, that's inertia of direction in action. So, yeah. So, second one is Newton's first law. We all know who Isaac Newton is, so I'm not gonna talk about him, but instead I'm going to be talking about his first law of motion. So, what is it? So, according to Isaac Newton, a body remains at rest or moves with the constant velocity unless acted upon by an external force. Well, so what this basically is that this law basically explains inertia, which we talked about. It tells us how that force is needed to change motion and not to maintain it. So, yeah. What are the fundamental forces of nature? There are four fundamental forces that control everything in the universe. There's gravitational force, acts between masses. Then there's electromagnetic force, acts between charged particles. Then there's weak nuclear force, responsible for radioactive decay. Then we have strong nuclear force, holds atomic nuclei together. So yeah, each one has different strength and range. So yeah, I'm going to be talking about them. So, what is gravitational force? Gravitational force is the force of attraction between any two objects with mass. It's why objects fall and why planets stay in orbit. Here, g is the gravitational constant, and m1 and m2 are masses. R is the distance between them, so we can say F equals g times m1 into m2 by r squared. So, yeah. Even though it's the weakest force, it acts over very large distances. And then we have electromagnetic force. So this force basically acts between charged particles and can either attract or repel. So it is much stronger than gravity and it's responsible for electricity, magnetism, light. So you get the point. Basically, most of what we see and interact with daily depends on this force, electromagnetic force. So yeah. And then we have weak and strong nuclear forces. So weak nuclear force acts inside atoms and responsible for radioactive decay, and it has a very short range. So yeah, keep that in mind. And now we have strong nuclear force. It's the strongest force in nature, holds protons, neutrons together in the nucleus, works only over extremely small distances, and without strong force atoms wouldn't even exist. So yeah, that's the thing to know. And now we have balanced and unbalanced forces. So what is a balanced and an unbalanced force? So balanced forces are basically equal and opposite. No change in motion, you get the point. And unbalanced forces is basically causing change in motion, acceleration, stopping, turning, etc. And net force is not zero. So yeah. And so what is momentum? Momentum is the quantity of motion an object has. It depends on mass and velocity. It depends on heavier or faster objects. So basically, if heavier might have, like, let's say, a little more less momentum than something like faster objects, or you get the point. So yeah. So what happens during a collision? It's also explained in this chapter, so I'm going to go through it. A collision occurs when two objects hit each other and interact with forces. The key principle here is the law of conservation of momentum. Total momentum before collision equals total momentum after collision. There are two types: elastic, no loss of kinetic energy, and inelastic. Some energy is lost as heat or sound. So, yeah. So, now we're going to talk about Newton's second law, law of motion. So Newton's second law explains how force affects motion. Here comes the really famous and popular formula F equals ma. So this basically means that force is directly proportional to acceleration. Force is also related to mass. So heavier objects may need more force to accelerate. And so we have next at Newton's third law of motion. So for every action, there is an equal and opposite reaction. Examples: walking. You push the ground and it pushes you forward. You might not like exactly feel it, but it is happening. And like rocket launch, gases go down and rocket goes up, etc. etc. You get the point of this example. Basically, whatever you're doing has an opposite reaction. You punch something, then the wall basically punches you because your hand hurts, right? So that's basically the wall punching you back at the same force. So yeah. So now we're going to talk about frictional force. So friction is the force that opposes motion between two surfaces in contact. There are some types such as static friction, sliding friction, rolling friction, and some effects are helps in walking and gripping, produces heat, causes wear and tear, and like yeah. So what are the effects of force on motion? A force can start motion, stop motion, change speed, change direction, change shape of an object, depending. So, like, yeah, from inertia to nuclear forces, everything comes down to how forces act and interact and how motion works. Once you look in these concepts and formulas and etc., you get the point of this, and like, yeah, everything becomes much more easier. So yeah, that was today me talking about our third chapter, and that's all for today. Thank you for listening to me, and yeah.